Good day, engineers. Ngayon, nandito tayo sa part 4 of our video for the code progression on the analysis of single reinforced beam. Ngayon, ibibigay ko na sa inyo kung paano i-determine yung exact reduction factor from 0.65 to 0.9 nung beams natin. So, it is under the provision of section 421.2.2, which states that strength reduction factor for moment, axial force, or combined moment and axial force shall be in accordance with table 421.2.2. So, sa table 421.2.2, nakita nyo dyan na andyan yung dalawang types ng strain natin or strain conditions. Nandyan yung compression controlled at andyan yung tension controlled. So, as you can see, meron din tayong net tensile strain. So, kaya sabi sa inyo, napakalaga nung net tensile strain natin kanina, which is can be computed using the depth of the compression block and yung strain diagram natin. So, mamaya ipapakita ko kung paano siya na-determine. Ngayon, ang gagamitin natin dito is yung parts ng others, kasi itong spiral conforming to section 425.7.3 is part of the discussion for the columns. So, yung others kasi na tinutukoy dito is for beams and yung other types ng columns other than the spiral column. So, focus tayo on this part of this table. So, dito lang tayo. So, sabi doon, kapag compression controlled siya, ang net tensile strain natin is lesser than or equal to ETY. So, what is our net tensile strain? Sabi ko nga, yung net tensile strain natin is galing yan dun sa strain diagram natin, which is, kung ito yung strain diagram natin, so let's say meron tayo ditong E sub C, which is 0.003, tapos meron din tayo ditong E sub S, so let's say yan yung centroid or galing sa centroid ng reinforcement, which is the tensile strain. Yung net tensile strain is galing sa first layer ng reinforcement natin, which is ito. So, galing lang yan dito sa diagram na to. So, as you can see, ito yan. So, paano ngayon natin kukunin yung net tensile strain? Si net tensile strain, makukuha natin yan using our strain diagram. So, alam natin kasi na this one is the value C. And alam natin that this height will be dt. Kasi this one is our D. So, for getting the net tensile strain using the strain diagram alone, we should get it by ratio and proportion. So, that will be 0.003 over C is equal to, ang triangle natin sa baba is a value. So, this one, yung height ng triangle natin, will be dt minus C. So, ibig sabihin, we will have epsilon t over dt minus C. So, yan ngayon yung pangkuha natin nung net tensile strain natin. So, we arrange the term, we will have a net tensile strain coming from this equation, which is 0.003 dt minus C over C. So, ito ngayon yung net tensile strain natin. Pwede rin, nakuhanin natin siya from the principle ni strength of materials that epsilon sub t is equal to, or epsilon is equal to the stress divided by our modulus of elasticity E. So, ibig sabihin, we can get epsilon sub t by getting the stress on the extreme tension reinforcement or dun sa tension or dun sa first layer ng tension reinforcement, and divided by RES, which is the 200,000 megapascal or the 200 gigapascal. So, yun ngayon yung gagamitin natin for getting the net tensile strain. Ngayon, what is epsilon T sub y naman? Epsilon T sub y, yan yung, so from the principle na lang yan ng epsilon T sub y is equal to, from the principle ng strength of material, that is stress divided by the modulus of elasticity. And since that is epsilon T sub y, ibig sabihin lang nun, pinapagamit niya sa yung stress is yung yield strength ng ating steel. So, ibig sabihin, that is Fy over our ES. So, kung gusto natin computein yung iba't ibang epsilon nung steel natin, meron siyang provision dito ng NSEP, which is stated in section 421.2.2.1. So, for deformed reinforcement, epsilon T sub y shall be Fy over ES. So, tama yung binigay kasi yung equation. Nababanggit din siya dun sa NSEP. And sabi dito, for grade 280 deformed reinforcement, it shall be permitted to take epsilon T sub y equal to 0.002. So, that is very specific. You are given a grade 280, which is the 276 megapascal steel, or ito yung mga steels which are having an Fy lesser than 400. So, pakita natin isa-isa. So, let's say, kasi ang mga Fy natin na binibigay on our problems is, meron tayong Fy which is equal to 414 megapascal. So, pag 414 megapascal yan, ang epsilon T sub y natin dyan is equal to a value 414 divided by 200,000. So, that will be an epsilon T sub y equivalent to 0.00207. So, yan ngayon yung epsilon T sub y for an Fy na 414. Then, for an Fy na 415, we have an epsilon T sub y which is equal to 415 divided by the 200,000 na modulus of elasticity. So, we will have an epsilon T sub y equal to 0.002075. So, that is for Fy is equal to 415 megapascal. Now, pwede din natin kunin yung part na 420. So, that is Fy is equal to 420 megapascals. So, epsilon T sub y will be equivalent to 420 divided by 200,000. So, that is an epsilon T sub y equivalent to a value of 0.0021. So, yan ngayon yung para sa 420 megapascal. Ngayon, proceed tayo dun sa Fy na sinasabi kong 400 megapascal. Kasi yung binabanggit sa code is 280 megapascal or 276. Pero kasi ang limiting value nun is yung 400 megapascal. So, pag mas mababa sa 400 or equal sa 400, that is assumed to be 0.002. So, makikita nyo dito bakit. So, that is equal to epsilon T sub y is equal to 400 divided by the value 200,000. So, our epsilon T sub y for this value of Fy will be equivalent to 0.002. So, as you can see, automatically, pag 400 megapascal yung Fy mo, ang epsilon T sub y mo, 0.002. So, ibig sabihin, pag bumaba pa sa kanya yung Fy, automatically, sabi ni code, gamitin mo na agad yung value na 0.002. So, that's make logical na if Fy, so gagamitin na yung epsilon t sub y na 0.002 kapag ang Fy mo is lesser than or equal to 400 megapascal. So, that will be for the values ng epsilon t sub y. So, doon natin siya nakukuha. So, ngayon, balik tayo dun sa pagkuha ng reduction factor from the table. So, kung epsilon t sub y mo naman daw is mas maliit compared dun sa epsilon t na hinahanap at mas maliit siya dun sa value na 0.005, sabi, nandun ka daw sa part ng transition zone. And ang pinapagamit niya sa'yo is this equation, which is 0.65 plus 0.25 times epsilon sub t minus epsilon t sub y divided by 0.005 minus epsilon t sub y. So, kung given to sa problem or open NSCP naman yung exam or yung quiz nyo, so, pwede nating gamitin automatically itong equation na to. Then, kapag naman ng condition is yung epsilon t sub y is mas malaki or equal sa value na 0.005, that is considered as tension controlled. So, ibig sabihin, ang value daw dun is 0.9. So, dun natin nagagamit yung exact values na 0.65 at 0.9 kapag ganito yung conditions ng strains natin. So, ngayon, paano kung hindi given si NSCP? Paano kung hindi mo kabisado tong equation na to? So, to explain it further, meron tayong ginagamit dyan na reduction factor versus the strain na diagram. So, as you can see, we plot on the x-axis si strain or yung net tensile strain, and we plot on the vertical axis yung reduction factor. So, mag-focus tayo on the line ng others. So, etong lines na to. So, as you can see, itong diagram na to, sinusunod niya yung kung ano man nakalagay doon sa NSCP. So, ito yung point ng epsilon t sub y. So, kapag mas mababa sa kanya, nandun ka sa compression controlled part and automatically nakita mo yung straight line. Ibig sabihin, ang value ng reduction factor for this lesser than epsilon t sub y na values ng strain is 0.65. So, paano kung nandun ka na in between the epsilon t sub y at yung 0.005? So, yun yung transition zone. And as you can see, meron ka ditong line na part na paakyat papunta ng 0.9. And at exactly 0.9, ang strain mo daw dapat is 0.005. And kung mas greater pa yung net tensile strain na makukuha mo sa 0.005, so ibig sabihin 0.9 pa rin yung gagamitin mong reduction factor. So ngayon, ang magiging problem mo is paano kung lumapag ka on the transition zone. Tapos hindi mo kabisado yung equation na binigay sa'yo ni NSCP. So ang gagawin mo is to use or utilize the equation of the line. The equation of the line for this one will be equivalent to a value y is equal to mx plus b. Yan ngayon yung gagamitin natin para ma-utilize natin yung lines kung wala man tayong given na yan CP provision at kung kabisado mo naman itong diagram na to. So, madali lang naman siyang kabisaduhin. So, let's take this point as an ordered pair point epsilon t sub y, so x kasi natin yun, and 0.65. Then, let's take this point as an ordered pair 0.005 and 0.9. So, using the slope-intercept form. So, kunin natin yung slope. Alam natin na slope is the rise divided by the run. So, ang rise dyan is ito. Yung distance na to. So, that is a value 0.9 minus 0.65. Now, our run will be ito, which is a value 0.005 minus epsilon t sub y. So, sin lang natin. So, run natin will be 0.005 minus epsilon t sub y. So, yan ngayon yung run natin. So, our slope can be simplified as a value that is 0.25 over 0.005 minus epsilon t sub y, which is also equivalent to a value 1 over 4 times 0.005 minus epsilon t sub y. So, yan ngayon yung slope natin. Siyempre, after getting the slope, we will proceed in getting the value of our y-intercept. So, our y-intercept will be produced by substituting the value of the slope, then getting the ordered pair or getting a coordinate from the line. So, let's say, ang kunin nating coordinate will be ito, yung epsilon t sub y and 0.65. So, substituting to the equation of the line, so, ang y natin is 0.65 is equal to, yung m natin is 1 over 4 times 0.005 minus epsilon t sub y. Then, yung x natin is yung epsilon t sub y plus b. So, arranging the term, we can have b is equal to 0.65 minus epsilon t sub y over 4 times 0.005 minus epsilon t sub y. So, yan ngayon yung y-intercept natin. Then, we can now substitute that one to the original equation, and remembering that y is our reduction factor and x is equal to our net tensile strain. So, that will be an equation na mapoproduce natin, which is a value. So, that is, the reduction factor will be phi is now equal to, so, substitute natin yung m, which is 1 over 4 times 0.005 minus epsilon t sub y, times mo yung, substitute natin yung x, which is epsilon t, plus yung y-intercept natin, which is 0.65 minus epsilon t sub y over 4 times 0.005 minus epsilon t sub y. As you can see here, itong equation na to at ito is pwede nating pagsamahin ng iisang equation. So that is, our reduction factor will be equivalent to 0.65. That is plus epsilon t minus epsilon t sub y divided by 4 times 0.005 minus epsilon t sub y. And as you can see, this was the equation na nasa NSCP 2015. So, ibig sabihin, ito siya. Kasi that is 4 lang naman eh. So, 1/4. So, 1/4 is still 0.25. So, napalawas natin yung equation na yun by just applying the rules of the equation of the line. So, ibig sabihin, kapag may mga values ka na dyan, kagaya ng epsilon t sub y, hindi na natin kailangan sigurong kabisaduhin to, basta alam mo yung flow ng diagram for our reduction factor versus the net tensile strain. So, Basta meron kang ganitong diagram, or basta alam mo tong diagram na to, papalabas natin yung ating reduction factor kapag nandun ka sa part ng transition zone. Kasi automatic kapag nasa compression controlled ka, the reduction factor is 0.65. Kapag greater than ka ng 0.005, nandun ka sa part ng tension controlled, which is ang reduction factor natin is 0.9. So, doon lang naman nagkakaroon ng equation kapag nasa transition zone ka. So, para sa topic din na to, isingit ko lang. So, yung value ng net tensile strain kasi natin dito, since that is equal also to FST over ES, so pwede natin kasi itong i-substitute ito papunta dito. So, as you can see, pwede nating gawin na ang equation nun is FST over ES is equal to 0.003 times times dt minus C over C. Ngayon, pwede nating dalhin doon si ES, which is FST is equal to 0.003 dt minus C times ES divided by C. Si ES, that is 200,000 megapascal. So, ibig sabihin, pag i-multiply natin yan kay 0.003, ang lalabas na equation will be FST is equal to 600 times dt minus C over C. So, ibig sabihin, ito rin is isang factor na pwede natin gamitin para makuha si net tensile strain. Kasi makukuha na natin yung net tensile stress dun sa first layer nung reinforcement natin. So, that will be all for this fourth part of the video on the concept of the analysis of singly reinforced beam. So, these are all the code provisions and formulas to be used for the analysis. So, again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.